What's up, Node.js developers? Welcome back to another live tutorial. Today, we're going to have another AI agent tutorial, another AI tutorial that is going to help and teach you how to build an AI agent from scratch using LangGraph as with an aspect of RAG. Today, we're going to learn more about all of these terms, what they mean, and I'm so excited about everything that is happening right now in the AI world, like what's possible to build, what powerful tools we have available at our fingertips, and how easy it is to actually implement them after we understand how they work. And the goal of these tutorials is to help you make sense of everything that is going on out there and to give you these ideas of what is possible. So make sure to follow along this tutorial by the end, and I promise you that you're going to know more about AI agents and how to build them, know more about RAG system and how to build them. And by then you're actually going to have a system, an AI agent with an interface with backend deployed and accessible by anyone that can answer questions about YouTube videos. So the project that we're going to build today is the AI chat with YouTube videos. And what do I mean by that? Let me give you a little context that one of the most powerful applications of LLM nowadays is to build these sophisticated question answering bots that have knowledge about a very particular area. Because we most probably all have already experienced general purpose LLMs, such as the ChatGPT, let's say, from OpenAI, that is exceptionally good at understanding human language and generating text, answering questions or continuing text generation. However, the general purpose AI models, they do not know very specific information. So while it's a very good generalist, when it comes to specializing in a very specific topic, it's not very good. It doesn't have most up-to-date information out of the box. So for example, if we ask a question about a documentation or about like a document, a law or something like that, it can get a little bit lost. However, if we as developers give the right information to the LLM can use that information to generate an accurate and up-to-date answer, which makes this system so powerful. This system of injecting context into LLM is called RAG, and that's what we're going to use today. And in our project, our system is going to get information, is going to get a YouTube video. We're going to do some magic there to scrape that transcript of that YouTube video so we know what's being talked in that YouTube video. And then our AI chat is going to be able to answer questions very specific to that YouTube video, such as what is the main topic of a podcast, how much money did, for example, he invest in these games, like very specific of what's being discussed there. And what's going to happen is our AI system is going to go ahead and get the part that is most relevant to this question, and based on that part of the interview is going to generate an answer. Or, for example, it can take an 8-hour tutorial from our channel, and you can ask questions like, what tools did Vadim use there? He's going to look through the video transcript, is going to find the information there, and is going to give you an answer. Or maybe you can use it like, I get an error, did I miss anything? And again, it's going to use the brain power of an LLM with the context of a video to give you the right answer. And this is actually how I came up to this idea. I was thinking about building an agent that can answer questions based on our videos. For example, you might be searching for a tool and you want to know in which video we implemented. You can use this agent to ask, and it's going to go and knowing all the information about our videos is going to answer where that is happening. There are a lot of applications of this kind of powerful bots, from analyzing public data, like on YouTube, chatting with long text, with long laws, with blog posts, with podcasts, and much, much, much more. So If we talked about RAG, let me quickly discuss more about that. So what is RAG? RAG stands for Retrieval-Augmented Generation. And in simple terms, generation means the part of an LLM that generates text. You give it some text, usually, let's say a question, and how it works, it generates what is the most probable next part of a text that comes after that, usually an answer, for example. Retrieval augmented means that it first retrieves context that it needs, and it augments, it improves the generation part using the information retrieved. So in our case with YouTube, it first will retrieve information about the video, about the transcript, and then using that information is going to generate the answer. RAG has usually two parts in it, and the first part is in the pipeline is an indexing pipeline. This usually happens offline, not when the user requests something, but beforehand, and that usually happens in following steps. First, we have to load the data. This can be documents, this can be HTML, JSON, URLs, PDFs. We need to get the data that we want to work with. After we get the data, we have to split it into manageable chunks, because if we have like thousands of characters into a document, it's going to be harder to, there is a limit to how much context we can give an LLM. And it would be better to split it, and then when we have a question, only get the chunks, the pieces of data that are relevant to that question. After we split the documents into small chunks, what we do is we embed. Embeddings, in simple words, means we take a bunch of text, we put it through a system, and then we get a vector. And a vector is basically an array of numbers. Array of numbers that represents a vector in a very multi-dimensional space. To think about a vector, very simple one would be a two-dimensional vector that is an arrow pointing into one direction. And having this vector, later we can compare it with other vectors to know how similar they are. That's basically how similarity search in this system works. We take a text, we generate a vector which is a numerical representation of that text. After that, we take it. In the next step, we're going to see how we find the similarity. So after we generate these embeddings, and again, it's important to understand the concept of it. It's not very important to understand how this is happening, because it's a matter of calling an AI model that is built for generating these embeddings. So think about it as a function. We give it text, it gives us back an array of numbers, which represents a vector. Having this vector, we need to store it somewhere, and we need to store it in a database that can support querying based on vector similarity. Basically saying, give me documents that are very similar to this document based on these numbers. After we have stored data there, we are ready for the next step. The next step is retrieve and generate. This usually happens when the user interacts with our system, when it asks a question. So the user asks a normal question in a very human readable language. It can have mistakes and so on, but LLM is smart enough to embed it, and based on the embedding of a question, which is the same process as here, we are finding the documents that are related to that question, that are very similar to that question. Then we see which of these documents are the most relevant document to this question, most relevant pieces of parts of our text relevant to the question. We retrieve it from the database and we put it as context in the prompt. Then this prompt, we send it to a normal LLM, such as OpenAI models, and then we get an answer back. But the answer has the context, so it's very specific to the data that we gave. Let me know if that is clear. But we're going to understand it, and I'm going to explain it again and again as we implement all of these steps. Let's talk a little bit about the architecture of the application that we're going to build today. So first, we're going to have a chat interface. We're going to build that with React. The chat interface is going to interact with our AI agent, which is going to be in our backend. We're going to build our backend with Node.js. I'm a JavaScript developer, so I feel more comfortable building with JavaScript, but if you're a Python developer, LangGraph is also available for Python, and I know a lot of people prefer Python in these situations over JavaScript, but I think it's perfectly fine with JS as well. So the backend is, in our case, is going to be an API that is going to contain multiple parts. One of them is going to be our AI agent, and the AI agent in this case is a simple abstraction on top of an LLM, the large language model provided by either Anthropic or OpenAI. And these providers like Anthropic and OpenAI, they are very interchangeable. So use the one that you feel best. In this situation, we're going to have a simple chatting application such as ChatGPT that we can ask a question, it can answer us back. Nothing more than that. It doesn't yet have context about YouTube videos, but we need our chat interface to know and to talk about the YouTube videos that we want to talk about. For that, we're going to have to index our YouTube videos to build this RAG system. So if we look at the flow, we have to load the data first. How we're going to load the data? Well, the data, we're going to get it from YouTube, and we're going to do that using the web scraper provided by BrightData. If you don't know about BrightData, this is the best tool to scrape and get access to public data on the internet. They run on a very powerful proxy network and are implementing a lot of features of unblocking the web for you, like solving CAPTCHAs or rotating IPs. And basically, you can think about okay, I need data. I don't know, and I don't want to care about how to get it. I'm just going to go on BrightData, and there you most probably will find an API pre-built for scraping this data for you. If not, you can use the scraping browser and implement this yourself. And in the world of AI, with BrightData, you can give basically access to any data on the web to your AI, because the power of our AI models depends on the power of the data that we provide or give it access to. So with combining BrightData with AI models, I think this is a very good combination and powerful one that unlocks you so much possibilities. So we're gonna use BrightData to scrape YouTube videos, specifically the transcriptions, the captions, and then we're going to need to, if we're looking back into this one, we need to split and embed it. For that, we're going to use an LLM, such as OpenAI, that is specifically an embedding model, not a generation model. Embedding means we give you text, you give me back a vector. After we have a vector, we need to store it somewhere. We will store it in a vector database. So it should be a database that can do these queries on vectors, like similarity queries. And Postgres has a PG vector that is an extension allowing to do this kind of similarity search on Postgres data. So we're gonna do that as well. We're gonna create a database, we're gonna store the data there. And that is the first step done. For the next step, when the user asks a question, we need to retrieve this data and generate it. So that's where our AI agent, we're going to have to give it access to our vector database to retrieve the information that it needs to generate the answer. Whew. So finally, we're going to deploy everything to Genezio, both the front end and our backend for the AI agent and the API. And if you don't know about Genezio, this is the best way to deploy web applications. They support a lot of frameworks, both front-end and backend, and that's what I like about it, because I can use Genezio to deploy both the front-end and the backend of our application, and we're gonna have everything up and running very, very fast. And I would like to say thank you to Genezio and to BrightData for making this video possible. Very excited. If you are also excited, I think we can get started. Let's roll the intro. All right. So I want to mention that the step-by-step guide, as usually, is in the link in the description below. So if you go ahead under the video, where is it? And open it here, you're gonna see the guide. So go ahead, open it up, go to site, leave your name, email, and you're going to receive access to the guide, to the Notion guide. So let me copy the URL as well to open it up here with you. And here you're gonna have like more step-by-step, and I left here a little bit more resources where you can learn more. So we're gonna use a lot the blog from Langchain, because we're going to use Langchain to build our AI agent. And they have here a two-part blog. However, not everything from here is super applicable to our case. So I would recommend you read here to know more, or follow what we are going to do, and we're going to do everything step by step. For that, let's go ahead and open a terminal and get started. I cannot wait to get started. I'm going to zoom in here. Let's navigate to our projects, YouTube 0320, like this. And let's create a directory. Let's call it chat with YouTube. Let's call it AI chat with YouTube. Let's go ahead and open this folder in our editor of choice. I'm going to open it with Cursor. You can open it with Visual Studio Code or any other editor of your choice. In my case, using Cursor is going to speed up a little bit the development process, because nowadays I feel more and more often using AI code generation to speed up my process. Today I'm going to use it only in specific cases where it's going to save us time, but when it comes to learning the AI agent, we're gonna try to write everything ourselves. So being in this folder, in this project, we're going to create first one folder called server. And this folder, I open up terminal and did mkdir server, where you can simply do new folder here. And let's go ahead and do cd server in our terminal and initialize our Node.js project. I'm gonna do that with npm init-y, and in our server we have package.json. While we're here, maybe we can even do here type module to be able to use like normal import statements. And for now, that's it. In a second, we're going to install dependencies here. But for now, let's go ahead and simply create the agent.js here, because the first step in our case is going to build our agent. Here, let's just do console log hello world. In our package.json, maybe I don't need it. I will just go ahead in the terminal. Being inside the server, I'm going to do node agent.js. And if I do that, we're going to see hello world. So that's how we're going to start initially testing it. We're going to simply execute this agent file. Later, we're going to put it inside behind an API so we can fetch and integrate it from the client side, from the front end. Perfect. Let's go ahead and there is also a blog post which I did 2 weeks ago around building AI agents with LangGraph. That one is really a step-by-step implementation of how to build this kind of agents. And I will open it up because there I showed you how to get started with that. What I want to do is I want to first install these dependencies. I will install Langchain LangGraph, Langchain-core, and Langchain Anthropic because I'm going to use Anthropic for the LLM, for the completion model. And then also Zod. We're going to see why we need Zod in a moment. So let's copy this command from here. I'm, by the way, also going to add it here in the steps. Actually, you can go in the steps and take it from there. And being inside the server here, let's go ahead and install Langchain, LangGraph, where is it? LangGraph and Zod. Now we need to create a .env file where we're going to write the, how is it called? We need the environment variable with Anthropic key. To get the Anthropic key, go ahead on anthropic.com. Go ahead and do build with Claude, do learn more, start building, and in your after signing in your account, you're going to be able to generate an API key. By the way, Anthropic is not the only way to do that. You can easily integrate with OpenAI as well. However, I tried with OpenAI and I didn't really like the performance, like how it behaved there. So I don't know, maybe I didn't try the right model from OpenAI, but we're still going to use OpenAI in the next step for something else. So in the embedding, what we need to do in the .env, we need to provide here the API key. Actually, let me go ahead and Anthropic console.anthropic to generate a new key that we can easily remove later. I need the how is it called? Console Anthropic. I just don't remember the account that I used. Okay, here it is. So what I'm going to do is I'm going to go into the API keys. I'm going to click generate key and I'm going to say here chat with YouTube key. Let's do add. I'm going to copy it. I'm going to also delete it later. Don't worry. And here, let's put it into Anthropic. Come on. Anthropic API key. And let's put the API key here. Let's also go ahead and add a new file here, .git ignore without dash git ignore, and add the .env file there because we don't want to commit the private key of our models to our Git. While we're there, we can also put the node modules. Perfect. Now that we have Anthropic key here, we are going to have access to it through process.env. But what we're going to do is we are going to use it to create the Anthropic chat client. So in our agent, what we need is first we need to import chat Anthropic from Langchain Anthropic. Then we need to say, hey, our LLM is going to be a new chat Anthropic, where you can also specify here the model that you want to use. For example, 3.5 like this, or maybe you can even do latest, or now we can do 3.7 if we want. You can also provide here the API key, but if you don't provide but inject it as Anthropic underscore API underscore key with this name, it's going to automatically take it from there. So we're gonna see like if it has it. Next, we will create a React agent. React, not from React.js that we use to build interfaces. It stands for reason and act. So it's going to be an agent that can reason and use tools for us. We just give it like what's possible, and it's going to decide how to execute everything to provide the answer. We're going to see in a second like what I mean by that. To create one, we're going to import create agent from Langchain core. Let me see where from. Langchain / lang graph / pre-build, if I'm not mistaken. Now we can say that, hey, our agent is going to be this agent, and an agent needs, first of all, the LLM. The LLM, which is going to be how it's going to complete stuff. But it also needs a set of tools. In our case, we do not have tools yet, so we're gonna give an empty array. In this case, this agent is really dumb. It's a simple LLM, but later we can add tools so it can do more stuff. Let's go ahead and test it out by saying, hey, I want to do an invocation of this agent with what's the capital of a moon? That's a very interesting question. Let's see the result. And to test it out, I'm going to simply execute this agent.js. If I do node agent.js, we're going to see an error saying that the create agent, right? At Langchain - lang graph - pre-build. Isn't it from there? Oh, create React agent. I forgot that. So yeah, create React agent. So in this case, it's not input, but it's what? I think it should be messages, right? Messages. Let's see how to invoke it properly. What is the capital of the moon? I don't know. It says it has a red warning here, but I think it's going to work. Maybe. We'll see. We'll see. No, I don't think it will. So it's actually should be, we need to give it an array of messages. And one message will have role user and content, what is the capital of a moon. Very similar to how a chat interface will look like. You have an array of messages. The last one is from the user, and the result is going to contain the list of messages. And what we are interested in is actually the last message. But let's see if it will work like this. If I do node agent, what we see is the API key, Anthropic API key not found. That's because even though we set it up here in the .env, when we executed node agent.js, we should also provide the env file equal .env. So we need to load the environments from that file before executing the file, the agent. And just like that, we have the answer. We have messages. We have a human message and we have an AI message. This is ID content. The moon doesn't have a capital city because it doesn't have permanent and so on. So cool. That's basically our list of messages. So to get the last one, usually what we do is we say results at -1 to take the last message from that array. And then we look at the message.content. And if I execute it again, we should see just the answer. No? Oh, it's results.messages.content. So results.messages, that's the array. We take the last one and we display the content. If I run the file, we see a simple answer like this. Perfect. Let me know, what do you think we should do next? Do we connect this simple LLM? Because at the moment, this is a simple LLM. Like, we called it agent and we use like an agent, but this doesn't make it a true agent. Why? Because an agent needs a set of tools, and the agent is going to receive an input, for example, a prompt, and is going to first create a plan for itself by calling different tools, by gathering different data. It's going to create a plan, and it will do that over and over again until the LLM is happy and said like, okay, this is the answer, this is a good answer, and it's going to answer it. So for that to happen, it needs access to tools. We're going to do that later, and one of the tools is going to be to retrieve information about like videos. But for now, our agent is a simple LLM. We can give it a question. It will give us an answer using the Claude 3.7 from Anthropic. Nothing too fancy. Now the question is, do you want us to build first the RAG system here in a server environment and test it with calling this function? Or do you want us to build the interface first and connect it with our server so we can interact from the client side, from the interface? What first? Maybe I know, but let's see, what do you think? And by the way, hello everyone who is joining us live. How are you doing, guys? I'm using Langchain in production. Want to try Llama Index. I haven't tried Llama Index yet. What's the benefit of it over Langchain, or what's the difference? I'm also learning a lot like about this AI lately, and I'm so excited what the possibilities are. Hello, Joshi. Hello, Rogelio. Hello, Blender Music. How are you guys? Hey man, you're doing a great job. Just finished your React Native 8-hour videos. What a content. Thank you so much. Thank you. I appreciate it. Is it possible to persist data between each agent tool calls? Yes, it's possible. And between agent tool calls, yes. And we are going to do it. We're going to persist the history of the chat so that you can ask follow-up questions. Okay, let me see. So I think we go RAG first. I also believe so, because RAG is the topic, the high part of this video, and I want to explain it well, because the client side is just the interface. So first we're going to interacted with this like this. Later, we're going to put it into an API and connect it to the client side. So we're gonna do both of them, but first, let's go ahead and build the RAG system. Okie dokie. So again, if you go into the, where is it? Well, first of all, in our presentation, if we look at the steps, the first one is going to be loading. Again, our plan for loading the data was to use BrightData to scrape the transcript of YouTube videos from YouTube. Let's go ahead and manually do that together with BrightData and get some very specific data of how this is going to look in the next step. For that, and by the way, this part of the video of scraping is sponsoring by BrightData. So thank you very much, our partners from BrightData, for enabling us to build such amazing applications and to unlock any data on the web. So follow the link in the description below or go to brightdata.com. And if you go to your dashboard, we're going to use their web data, where is it? The web scrapers. So go ahead, open web scrapers. And if we go into the web scraper library, these are pre-built web scrapers that give you access to data in a similar way as you would fetch an API. But actually that data is scraped in real time from the websites in a very secure and scalable way, so you can scale your project without any limitations. There are a lot of sources, data sources like LinkedIn, Instagram, Facebook, and so on. Even like e-commerce, like from Amazon and so on. What I'm interested in is YouTube data. So if I search here YouTube, we're going to see that there are actually 8 scrapers for YouTube. And the one that I need is video posts by URL. So let's go ahead and click on video posts by URL. There is also a link in our guide. Scraper API, let's do next. In the documentation of this API, we say that we just give a YouTube URL. We can give also a country where to look from. And as a response, we are going to get the data about that YouTube, such as the title, the video URL, likes, views, date posted, description, and so on. But what's cool is that we're also going to scrape the transcript. The transcript both in raw format, like the whole transcript like this, and also if you scroll down below, the transcript formatted with the duration, similar to how it appears on the video. So we're going to use this transcript from BrightData in our system to provide information to our RAG system to be able to answer questions about that video, giving information to the LLM like what's happening in that video. Let's go ahead in the API request builder and see how we would interact with BrightData to give us this data. For example, we're going to give inputs and we can do batch requests, so we can do multiple inputs per request. And here it's a simple URL of a YouTube video. For example, let me do 2 YouTube videos that I'm interested in. I'm gonna do one short one and one a bit bigger. Let's do, where is it? I'm going to do a short video to be able to see like what's happening, and later I'm going to also do a bigger one. Give me 1 second. Or maybe we should actually do my video, like some of my videos. Yeah, let's do that. For example, which one? I'm going to do a live stream. That one is going to be like huge. But maybe, yeah, we're going to test it with a huge video as well. Let me just grab, for example, this one. So I'm going to give a 7 minutes video from Formula One about today's sprint qualification. I haven't watched it yet because I'm preparing, but I'm very interested. I'm going to go into the BrightData API where it is here. And the first input is going to be this one. And the second one is going to be a longer video, like a 4-hour videos from our channel about building with React Native and Animated. Let's copy this URL as well. Send it as the second one. And what do we see? Here are some configurations to include errors if they happen. We can provide the URL where to send notifications. And I'm going to exclude this delivery to external storages. If I do that and copy this curl command and go into a terminal and open it up like this and paste the command here. Also make sure to add the API token here from your account. Like go ahead and first create an API token and add it here. And it's going to automatically be added to the command. What we're going to see back is a snapshot ID. A snapshot ID basically means that a job for scraping the data started. Usually scraping data takes some time. It's not instant because it has to actually simulate opening a browser and navigating to that page and interacting like a user would do. So if we look in the logs here, we see that a new job with this snapshot that we just copied from the console log, we see it here. What we can do is we can click download to JSON and we're going to have a JSON file. Let me take this JSON file and bring it in our server as, come on. I'm going to bring it here and I'm going to call it data. Let's call it .js to easier import it. I'm going to click save to format it and I'm going to add at the top export default. So what we see indeed is an array with two objects, the first one and then the second one. We see that this is the title of the video, sprint qualifying. We see this is the transcript. And then we see, if we scroll down for this transcript formatted, we're going to see the second video as well. Oh, come on. The second video is this one. And the transcript is what's up, not just developers. So now that we have this data, later we're going to automate how we start and how we get this data. For now, let's just import it from data.js. Let's import it in our agent.js and say, hey, import data from data.js. And let's say video 1 equal to data at position 0 or video. Yeah, let's do video 1. Because this is an array, we're going to look at the first video. Perfect. Here is the data. The next step that we have to do is we loaded the data. Now we have to split it. Let me splitting, we can do that in a very ourselves by simply looking at the transcript of that video and splitting it into chunks of 1000 characters. However, Langchain provides some pre-built splitters that are a little bit more sophisticated that is improving how this splitting works to not lose some context. One of these splitters is called recursive character text splitter from Langchain. Text, is it at Langchain? Isn't it like this? Like this, and probably I need to install it, right? npm install. Yes, let's install Langchain / text splitters. So here we're going to do split the video into chunks. For that, we're going to have to define a splitter using new recursive character splitter and provide here some options. As we can see, the default ones that are recommended here for me is chunk size and chunk overlap. So what does it mean? Chunk size means how large should the chunks of data be. Here we say it should be 1000 characters. And chunk overlap is going to simply repeat the last 200 characters from this chunk in the next one as well. In this way, if there is important context between these splits, we're not going to lose it. So even though it's going to lead to a little bit more data because it repeats 200 characters at the beginning and at the end, it's going to allow to give enough context and not lose it. Now, splitter like this is going to work. Splitter by calling split not text. We can do split text as well. Yeah, I think we can do split text. But we should actually work, a better way would be to work with documents. So we're gonna call split documents. For that, we need to have a list of documents. Let's call them docs. I'm going to define them a little bit here to the top, saying that the docs is going to be an array. An array where we create one of these documents with our video one. Let's say that the document needs page content, and the page content is what is inside that document. Inside that document, we're going to use the video1.transcript, which if we look into the data, video1 is this object and the transcript is this long text. So this is going to be the page content. The new document, the document should be imported from Langchain core documents. Now, if we take the documents and split the documents here, we have chunks. Let's see what are these chunks. Console.log chunks. If I open it up and run the do node agent, we're gonna see what? Anthropic key not found. Yeah, because we need to do with env file. So what we see here is that these chunks is an array with bunch of texts. The first 1000 characters, then the next one, and this all are documents. Documents. If we look at the last part, I'm going to even copy it and search for it. We're going to see that it's both here and both here because the text overlaps. And that works with this end as well. If I'm going to copy it, it's going to be both here and both here because the last part might be import information for this chunk, but it also can be import information for this chunk. Now we see that these documents also have this metadata. This is a great place to write additional data about those documents. So if I look into where we define this document here, we can define the metadata here as well. And one of the important metadata parts here is what video is this content transcripts about? Because later we're going to have a lot of videos, so we need to know like where is it coming from. We can call it video ID and say that the video ID is coming from video1.video ID, because if we look into the data, there is a video ID property here. Now, if I will execute this one again, we're going to see that in metadata we have video ID. Later, we can also filter only the documents that are related to this video. Perfect. So the splitting part is done. The next step is embedding. And embedding, if we look into the Langchain here, this is what? LangGraph, I'm going to find this one. As you can see, for the chat model, basically the model that will generate text, we can use these kind of available models. Grok, OpenAI, Anthropic, and so on. And actually more. But for the embedding, we need to use a model that is specific for embeddings. As I see, Anthropic doesn't have an embedding model, so that's why it's not here. For that, we can use OpenAI. You can see that OpenAI embeddings, you're going to see that maybe on their site or the documentation, is that they have this kind of models where you give as the input some text and you get back the embedding as an array of numbers, the vector of that text. So let's go ahead and say that we are going to use OpenAI as our embedding model. So let's go ahead and first install Langchain-OpenAI in our application. Let's make sure you are inside the server and install the OpenAI. And what we're going to need to do is we're going to import first we need the OpenAI key inside our .env. Go ahead, sign up for OpenAI, get a key, and I'm going to get it here. Let me do it like this. And I added it to the .env. Now we are ready to use OpenAI. What we need is to import OpenAI embeddings in our agent, OpenAI embeddings from Langchain OpenAI. After splitting, what we're going to do, let's do here embed chunks. To embed chunks, we need the embeddings using the new create, or how is it, OpenAI embeddings. And you can also specify the model here. I'm pretty sure there is like a default one if you don't specify, but know that you can specify what exact model. We're going to use the embedding free large that is going to produce a specific, like the model produces a specific amount of the size of a vector. So a large model, if not mistaken, should be around, I don't know, 2000 or something like that. Dimensions of that vector. So the more dimensions, the more nuances it can detect in the text. But at the same time, it's more data to store. The larger, it's more consuming. Okay, so the thing is that now that we have this model that can generate embeddings, we need a store somewhere to store that embedding, that data with embeddings. what we can do, if we look in the documentation, we need to pick a vector store. We need a storage solution that can store these vectors. Not only they can store it, but they can optimally query based on similarity. I'm going to start with memory because this is going to be the easiest one. It simply stores them in memory, and to get started, that's totally fine for us. Let's go ahead and import memory vector store from vector store memory at the top. And let's create the vector store where we have our embeddings. So this is the vector store, new memory vector store, and we send this embedding model. Finally, what we need to do, give me 1 second, is to let me think like how to introduce this one slowly. Okay, so what we need to do is say, hey, await vector store, add documents, and we're going to add the chunks that we generated here. As simple as that. How to visualize it? That's another question. Because, yeah, let's try right now, like, vector store. Let's try to simply run our project with no DNV file. We see a problem. Package JSON reader. Cannot find Langchain imported. I think we also need to install Langchain like this without add. npm I Langchain. Okay, perfect. Let's now try to invoke the agent again. And we don't see any errors. That means that everything went fine. The chunks should have been embedded and wrote to the database, but we do not see it. Like, how can we visualize what's happening there? Well, that's because we have simply done the first step of indexing, loading the data, splitting, generating embeddings, and storing the data. The next part is the retrieving and generating. Let's go ahead and see how we can retrieve documents from our database that are similar to a question. To do that, let's go ahead and say here, retrieve the most relevant chunks. So what we're going to do is we're going to say docs equal await vector store. We're going to work with this vector store. We're going to do a similarity search. A similarity search because we index the table, the data from qualifying. Let's do what season is this sprint in? I'm going to send a question similar to the context of a video, and I'm going to do a similarity search, meaning that I'm going to find the chunks that are more similar to this question. So let's see what is going to be the answer. Docs, we already have it, right? So retrieved docs. Let's do it like this. And we say, give me 5 docs. If I run the agent again, what we're going to see is the documents where at the top is the most similar one. I was expecting to see also the actual similarity, because here, how do I prove you that it's working? What if I something from the end. What was the finish time of Norris? And I'm going to select 1. And before that, I'm going to console log the chunks. And here I'm going to console log this one, but I'm also going to have like, so that we see. Let's go ahead and try to run it again. Initially, the documents are in chronological order from the beginning. The first one is personal best through the sector and so on. And at the end, we do a similarity search for the question, what is the Norris end time? And we see that here it's the document that is most related to the finish time of Norris. So we can use this text to try to answer that question by putting it through an LLM. Again, this is the similarity search. Let me see if I can actually get query filter callbacks. Query. Yeah, it doesn't give us the exact similarity value, but that's good. It at least does the similarity search. So what can we do here? Now that we can, having a query, a question, if we can find similar parts, similar transcripts from the video, we can use them, put them through the LLM here in the agent, so that it's going to use it to create the answer. For example, if my question here is going to be what was the finish time of Norris, it's not going to be able to give me a proper result, answer. Because this LLM, the agent, does not yet have access to our vector database. Or does not provide the information I have. So let's go ahead and build a tool that can use the vector store to retrieve the right information. Building a tool is also greatly documented and explained in our previous tutorial, build and deploy your first AI agent with LangGraph. Yeah, this is the tool. So what we need to do is import this tool. At the top, let's import the tool, and we are going to create it maybe here. Retrieval tool const retrieve tool is equal to tool, and we create it like this. We're going to have an async, and it should return something. A tool has two parameters. The first one is the actual function that is going to run. The second one is going to be some metadata about the tool. Let's give it a name, retrieve, and we need to also give it a description. Description is very important because that's how the LLM will know what is this tool supposed to do and when should it be used. Here, retrieve the most relevant chunks of text from the transcript of a YouTube video, something like that. It's also important to provide here a schema. A schema, we are going to define it with Zod. So let's go at the top and import Z from Zod. And Zod is a tool that can help us create schemas of how objects should look like. And a tool needs a schema so that the LLM knows what inputs, what data to send there. Let's say that the schema is going to be an object, and there will be a query, and the query is going to be a string. This query, now that we added it here, is going to be accessible through the tool execution function. So we can have query, and here we can say, hey, console.log retrieve docs for the query, console log query. I'm not going to do the similarity search yet. Let's just return an empty string. Norris was first, finishing in 33 seconds, which is impossible, but it's a way for us to test if this tool was invoked or not. Now, if we take this tool and we give it to our agent inside the tools here, the agent will know that, hey, I have a tool that has this description. It can retrieve the most relevant chunks of text from the video transcript. It will say that it's a question that might benefit from this information. It's going to look at the schema and it's going to create a query and it's going to call this tool. Then it's going to get back the result and we'll analyze and see what to do next. Let's go ahead and see what actually is happening now. I'm going to maybe comment out the logs that we did before. And I'm going to invoke our agent. That was bad. So what do we see? Based on the transcript information I found, Norris finished in 33 seconds and was first place. That's exactly what we kinda said, like it's not the right information, but where is it? Our question to our agent was, what was the finish time of Norris? You see, this is what we are asking. Then LLM analyzes this question and is invoking the retrieve tool. And in the retrieve tool, we are doing here console log query. The query is already different because the LLM was smart enough to change it in a way to get the data that it needs. So it simply changed it to Norris finish time. That's what an agent, that's how an agent improves a RAG system. Because the question is, can you build a RAG system without an agent? And the answer is totally yes. You can build a normal AI flow for a RAG system without this agent inside. It's simply doing it step by step in a sequence. First get data, then generate embeddings, then get similarities, then create the prompt, and then send it to the LLM. A lot of things can be done manually and in sequence. But having an LLM here, we see the first benefit is that the question that we ask is going to actually be transformed to something that is going to make a lot more sense for the AI to get the data. And we see that we faked some data here. So in the retrieval tool, we just said Norris was first and finished in 33 seconds. And then having this information, LLM generated the final answer that we see here in the response. Perfect. But let's go ahead and having this query, let's do this retrieval of docs. Because we have a query, we have a vector store, we can use the query inside a similarity search, and we can search how many chunks do you think would be relevant. Let's do 3 chunks. Maybe it's going to be in 3 different places. At the same time, the LLM can call this over and over again to get all the response. So F3 or maybe F5 probably is going to be enough. So now that we retrieve the docs, let's put them in a serialized docs, meaning let's merge them together. And what I'm going to do is I'm going to do retrieve docs. So for every doc, let's return I don't know, content doc.page content doc page content, and at the end I'm going to put a -n to say that it's the end. Or maybe I will simply do, let's simplify it. So I'm going to map for the documents, I'm going to leave an array of simply the content, and I'm going to do a dot join with a -n. Basically, what I'm doing here is I'm taking 5 or 3 docs that we get and put them in one single text. And I can take this serialized docs and return it here back to the LLM. Now, if I'm going to go ahead and execute the same query again, it's supposed to base its answer from the transcript that we actually fetched. So this is the query that our tool received. And we see, based on the information retrieved from the video transcript, Landowner is finishing in 6th position in what appears to be a sprint qualifying session. The transcript mentions Hamilton, Verstappen, Bester, Leclerc, Russell, Norris in 6th, we listening the order of drivers. So you see, it generated an answer based on the transcript. So that's, in a way, our whole RAG AI agent complete. If we look at this, we started with indexing first, and now we have this retrieval and generation. Having a question from a user, we provide a tool that can retrieve relevant information from transcripts from our vector database. And then using an LLM like Anthropic, we are generating the answer here. Perfect, no? Let me go ahead and initialize a Git. So you're gonna have access, because this is the base, but we are just getting started, guys. Let's do git add, git commit, basic AI agent with RAG. What's happening? Let me check the live chat. If you have any questions, feel free to ask them. I'm going to stop from time to time to answer them. I'm already building a project like this. Amazing. I had not started to do the video file pipeline yet, so this is perfect. This is a video file. We are not working with video files, we're working with transcripts of the videos. Sprint, but you said spring. Not sure when. Oh, it uses transcripts. That's how my project currently works. Yeah, perfect. What is RAG? RAG, as I was explaining earlier, is... So we have an LLM. An LLM is great at generating text. That's how it answers questions. You give it some text, which can be a question, and it tries to predict what should be the next part of a text, meaning an answer. It's very good at understanding language and at predicting what comes next, and it's very good at general information, but it's not very good at very specific information that either might not be public or it can be information that is super up to date, like what is today's weather. An AI LLM will not have that information. So what we are doing is we are giving AI access to a data source that we can index on the similarity based on a search term. For example, you have a documentation website and you want to build a chatbot that users can write how to initialize a new project. The chatbot will first look through all the documentation pages and will find the documentation pages that are more relevant to the question how to initialize a project. It might find 2 to 3 very relevant documentations. It's going to use the information from there. It's going to put it through the LLM back saying, hey, this is what user is asking. This is what documentations we have. Provide an answer to that question. So this part of injecting this data, retrieving the data, is what makes it a RAG system and allows it to be powerful in order to know like more data, more relevant data that you might need for specific use cases. So LLM with access to additional data. Have you figured out how to prompt cache the transcripts in this setup? What do you mean by that? Prompt cache. Let me know. Okay, so we have our agent that, where is it? It currently is doing a lot of stuff. It's loading data from our dummy data there. It's splitting it. It's adding it to a vector database by embedding. So a lot of things are happening here behind the scene, behind this line. Add documents. It's not simply inserting it to the database, but it's first generating these embeddings using the OpenAI model. Because having them inside of a vector store, we can later retrieve them based on a similarity search. Basically, hey, having this text, what is the most similar document for that text? And similar in terms of context. So we build a tool and we build an agent. We give that agent this tool that can retrieve documents. Perfect. In the next step, we're gonna clean it up a bit and start thinking about like how to move it closer to a production-ready application and system that can run on autopilot with multiple videos with a proper database, because right now we are using the memory vector store. And memory vector store is storing this data in memory, and as soon as I stop the server, it's lost. So for AI, there is prompt caching where the LLM will cache your input so it can be reused. So like with Claude, your cached input is like, if the input is $1, the cached input will be 115. But then you send the same thing again, it's cached, so the input is like 20 cents. Yeah, not sure how this is going to work here. I'd have to look into that. Okie dokie, okay. One second, guys. Let me think about something. Next, let me show you a small problem and fix it together with you. For example, we are asking the first question. Let's do it like this. Console log Q1 is going to be this one. And what if we go ahead and ask the question 2, which is going to be, what was the finish time of Verstappen? I don't know. Finish time or position. Or no, let's do it in another way. Let's do what about Verstappen. And here, what was the finish position and time? What I'm trying to do here, and let's do results 2 and here results 2, is I'm trying to simulate asking a follow-up question. A follow-up question might not have all the context. I mean, a good chat AI agent will understand that a question like this, what about Verstappen, is connected with a previous question. So it should be something like finish position of Verstappen. In order for that to happen, our agent should have short-term memory, or actually long-term memory, having context about like previous messages in the thread. Because if I do that right now, if I'm not mistaken, let me do cd server, let's do node and invoke it. It should answer correctly the question 1, what is the finish position? It failed to actually invoke the tool there. And in the question 2 about Verstappen, why did it ask about Norris? Wait a second. That's a bit weird because when I asked about Verstappen, it started doing about Norris. Because I'm stupid. Let's do what about Verstappen here. I left literally the same question. Based on video transcript. Let's try again. So for this question, it invokes the tool. It asks for nor is finish time. It doesn't like the response. It invokes it again. Nor is final time position. Oh, no. It understands that this question, finish position and time, it's split automatically into two requests. One is nor is finish time, and another one nor is final time position result. Amazing. And then by retrieving two sets of data, it was able to say that there is no specific time there in numerical format. And here, what about Verstappen? And what it says, I'd be happy to help you find information about Max Verstappen. However, I need to search through YouTube video transcript for relevant part. Could you please clarify what specific aspect about Max Verstappen you're interested in? So here we understand that when we ask second time a follow-up question, what about Verstappen, it did not connect it with the first question, and it did not understand that we mean like finish position and time. It's not clear here. For us, it's clear that the AI doesn't connect the two questions together, that it's the same interaction. For that to happen, we need to provide here to the agent a long-term memory, a checkpointer. So again, in the previous tutorial, I have here adding memory to our agent, and we can do that by importing memory from Langchain langgraph at the top. And somewhere here where we create the agent, we can say a memory saver, and we're gonna give it here as, if I'm not mistaken, is checkpointer memory saver. Checkpointer memory saver. Or if you want to save on some characters, you can call it here checkpointer and remove a duplicated because it's the same name. Now, because it has a checkpointer, we're not going to be able to invoke it like this. And if we do, if I'm not mistaken, we're going to have an error saying that now you have a checkpoint. We need to provide the a configuration with a thread ID. So using a thread ID, we're going to know like what other previous messages to connect it with. And that is going to happen when we call agent.invoke. After the whole invocation, we are going to have here a configurable, options with configurable, and here we're going to have thread ID. Let's say like, I don't know, thread number 1. I'm going to take these options and I'm going to add it to the second invocation as well. That way, connecting them together. And pay attention where I'm adding them. This is actually after the object that has the messages. It's not besides it. So it's two different objects. Now, if I'm going to send the same request here, what I expect is that the second question will understand that it's a follow-up for the first one. So it will understand that I'm asking about finish time and position for Verstappen. And we see that indeed it understood. So it's doing a search query in our tool for Verstappen finish time and position results. Finished second place, right behind Lewis Hamilton. Amazing. So that's not amazing that he finished second. Not a big fan, but amazing that it's working. So just by simply adding this checkpointer, that's what we managed to do, adding like more configuration here. Another thing that we can do here, when we invoke in the configurable, we can send more metadata. Things like, let's say, the video ID that we are querying for. Video underscore ID is going to be equal to, let's go into the data and say that we are working with this video ID. The first one, sprint qualifying. We can take this video ID and in the configurable say that in this thread, hey, we are talking about this video. Again, it depends on how you want to architect the experience, but if you want one thread to be specific to one video, that would be a good configuration. Later we can think about like how maybe we can send a channel ID here, or we can let the AI agent understand magically what video we are talking about. But this is a good way to send data, so I'm going to send it through configurable here. I will remove a second one because we had it just for testing. And I'm going to take this video ID and where are we going to receive it? I need to receive it somehow here in the retrieve tool. To receive it in the retrieve tool, this is the input of the tool, but here we get the options of the invocation, and we can go ahead and get access to the thread ID, where in this case I need the video underscore ID. So if I do here query console log video ID, let's see if in our tool we get access to the video ID from our invocation. If I call this one here, we see the ID here. It's still going to work the same because we just simply do this. But what we can do here is we can use the video ID for the similarity search. I'm going to show you the documentation where you can find it. Just Google LangGraph vector store and the JavaScript. For example, if I'm not mistaken here, and you're going to see that LangGraph vector Langchain vector store GS. So in the documentation, you're gonna see some options that you can use. I need options. Yeah, I'm pretty sure like you'll find here, like maybe I'm going to leave the link in the guide here so you can have access to it. But what I mean there is that when we do vector store.similarity search, the first one is query, the second one is how many items we want to receive, but the next one is the filtering, and the filter can be a filter on the metadata. So we can say that I want only the docs, or maybe I need filter here. Let me double check that. No, it shouldn't be filter. It should be simply video ID. So this is the filter that is being applied and is being applied on the metadata of our documents. And if we look in the metadata of our documents, we store the video ID here. Later, when we add the database, we're going to be able to see visually what I mean there. And now let's go ahead and see maybe console log retrieve docs to see what document docs did it receive for that query. I'm going to go ahead and invoke this one with a question, what is the finished position of Norris? It knows that it's this video ID because we specified it. It's going to ask Norris finish time, and it will say, I apologize, but it seems there is a technical issue with the retrieval function in order to provide more with accurate information. Basically, it says that there is no items with this ID. And why is that happening? Something wrong with here, with the video ID. Video ID. Did I call it video underscore ID here? Metadata video underscore ID. And let me look in the database. Video underscore ID. Video underscore ID. filter. This is the vector store similarity search. I'm wondering if this is not going to work for the in-memory vector databases, but only for the Postgres databases. Because as I see the retrieve docs, right? Retrieve docs for query. It doesn't even get here, so it must fail completely. It doesn't get retrieve docs. So let's try to do a try catch just to see why it's not working. It's hopefully is going to show me. But yeah, as I'm saying, maybe this kind of filtering doesn't work on the in-memory. Filter is not a function. Okay, so for the in-memory, maybe filter should be a function. Let's try saying that, hey, doc is a function, and we're going to return true if doc.metadata.video ID is equal to video ID that you're looking for. Again, this is going to be a bit different later, but now for in-memory database, I think it expects a function for filtering. And let's try to maybe remove a try catch and invoke it again. Okay, we see that, and we see retrieve documents, these documents. Cool. If, for example, I'm going to make a mistake and say, give me we are working with video ID 123. This video ID is not in our database, and it's supposed to filter out like other documents in the database. We see retrieve docs as an empty array, meaning that our filtering is working correctly. Now, what we can do is we can load the other video as well. Let me go ahead and maybe split up a little bit the logic of generating these embeddings, because I would like to already clean up a little bit here. This file is getting a little bit out of hand, and it is responsible for different pipelines, different layers. It's both for indexing and adding to the database, and it's also about the agent. I want agent to be only specific to agent. So let's go ahead and create here in the server a new file called embeddings. Hopefully I wrote it correctly. Maybe not. Is it with double D? Embeddings? Maybe. And from the agent, move stuff related to embeddings there. What stuff do I mean? Well, first of all, I want to move the creating the OpenAI embeddings and the vector store. I will copy them from here. I will cut them actually and move them here. I want to import what we need here. And we have here what? Export vector store. Maybe I'm going to do export const vector store so that our files can import this storage. I'll also do export const add documents to vector store function. Or not documents, but let's do add YouTube videos to vector store. Let's say we're gonna get video data and we need to do something with it. What do we need to do in order to add it to the vector store? Well, we already have it in the logic in the agent AI. If we look here, well, first we have to define the splitter, or actually the docs. So I'm gonna copy creating the documents, creating the splitter, generating the chunks, and finally doing vector store add documents. I'm gonna copy all of this into embeddings because this is part of adding a YouTube video data to vector store. So for the document, we need to import a document from Langchain core documents. Page content is going to be video data.transcript. Metadata is going to be video data video ID, or we can do it easily here, destructuring. And video ID is going to be like this because it has the same name and title. We need to import the recursive character text splitter from Langchain text splitter here. We're gonna leave the same configuration. We're gonna remove this console log, and we are adding it to the vector store that we created at the top. Vector store, add documents chunks. Perfect. So now this file is responsible for setting up the vector store and adding, for example, YouTube videos to vector store. Let's go ahead back and clean up a little bit here. We'll leave a retrieve tool here. I don't know, I don't need the video one, or maybe I need. Do I need it? I think I don't. Yeah, I need it because it's still going to be here that I want to add this video to our database. So for that, we need to import vector store and add YouTube video to vector store from embeddings. And I want to call here await add YouTube video to vector store. So I still want to add it here. Later, we're going to think where to do it. For now, I just want to, I move a code in another file and call it from here. I'm still going to have a retrieve tool that needs access to the vector store. So that's why we exported and we imported here the same access to the same database. And everything else is related to this one. I can clean up a little bit here the imports of what we do not need anymore, leaving only things that we need, like this. And what else? Cleaning up a little bit the console logs here as well. Checkpointer, video ID, okay. This one is also going to go away in a second, but it's testing the agent. Perfect. So let's double check if it still works. I'm going to invoke the agent.js. Question was the position of Norris. Come on. Based on, I can provide with more details. Hamilton Verstappen. Yeah, like we understand that it's working. It's using the transcript data. What I want you to do now is let's try to add 2 videos to the store and see that in that case it can filter out the transcripts related to one specific video. For example, I'm going to do a same await video, add YouTube video to vector store, and I'm going to say that we want to add the data at position 1. Here I can do data at position 0 and data at position 1. If I'm going to go ahead and ask the question about this video ID, about Norris, I think it's going to be fine because it's going to look only at the transcripts for that user. At the same time, it took a little bit of time to add the embeddings, but it's very fast, like it's super fast. Let's see what's happening now. I don't see a specific time for Norris. Mentioned that Norris racing that was going quickly through the middle part of a lap by 800 milliseconds. However, if I'm going to go into the data and take the ID of my second video, let's find it with video underscore ID, and the second one is this one. If I'm going to say it, hey, now this same question, what is the finish time of Norris, is going to be on a different video. What I expect to see is, I expect the model not to know how to answer because it doesn't have that information. We gave it information from a different video. Let's see. Based on the transcript, I don't see any information about Norris. The transcript appears to be discussing programming concepts. So that's exactly true because we are filtering out only data from our vector store for this video ID. If I will go ahead and change the question to what will people learn from this video, let's see what that answer is going to look like. Because remember, this video with this ID is a tutorial from my channel about Apple Invites application. So if we look at the response, it doesn't understand that it needs to call the tool. So let's see, what will people learn from the video based on its transcript. It still sometimes doesn't know that it has these capabilities. So maybe I need to inform it like, hey, at any moment you have information about video, you just need to call the tool. But with a better question, I think it's going to work better now. As we can see, it's thinking, and we see, based on the video tutorial about building a mobile application, how to create custom auto scrolling component, marquee, building onboarding screens with animation, implementing UI, React development concepts, and so on. So perfect. Now our AI agent can work with multiple videos. It can store this data in a database, but when asked, it's going to look at only specific information for a specific video. Whew, perfect. Let me go ahead and do a git add, git commit agent with rag. I'm going to bring some water, and the next step for us is going to be to change from a memory vector store to an actual database so that this data is not going to be lost and we're not going to have to generate the embeddings always. We're going to store and cache them so that next time when we ask the same question about the same video, we don't have to get the data again and again. So that's going to be our next step. Give me 1 second. Hello. Perfect. So, as I was saying, the next step is going to be to transform to a proper database for our vector store. And that's one thing that I liked about Langchain is how everything is abstract in different layers. And you're going to see how easy it's going to be to swap from a memory to a Postgres database. We just have to create it and change here how we connect it, and everything else is going to remain the same without us having to do much changes. For the database, we need a Postgres database. With Postgres SQL, there is a PG vector extension that enables us to do similarity searches and index database based on vectors, perfect for our embeddings. So we need a Postgres database. You can run it locally. You can use Postgres with a Docker to run it locally. That's totally fine. But I think it's a little bit more technical and maybe not everyone has the environment set up to run Postgres locally. What you can do is you can use, for example, neon.tech. And with neon.tech, it's actually super fast and easy to get a Postgres database up and running. And I think they also have a good free tier for up to 10 projects. Let's go ahead, sign up, and in your profile, go ahead and do a new project. I'm going to call it AI YouTube chat, and let's do create. Here, we need to enable Postgres database. So what we have to do is we are going to enable it by running a query in the SQL editor. The query, I don't remember how it was, but let's do enable PG vector neon. And that is going to be a query called create extension vector. So if I go into the SQL editor of my database on Neon and write this command create extensions vector and do run, it didn't like. Why it didn't like? Second time statement executed successfully, so maybe it was not ready yet. Now it executed successfully, so I enable this vector extension on our database. So our tables here will be able to have like vector columns and index and search based on their similarity. The next step is to simply connect to this project from our application. I'm going to go here and I'm going to copy the connection string. Let's go ahead and put it into that env file and let's call db URL and let's paste the connection string that we got from here. Make sure connection pooling is enabled. And the next step is to go and double check with where? With Langchain under pick your vector store, I'm going to select PG vector. And what I need to do is do npm install at Langchain community. Let's do that first. And then we can create this vector store like this. So from our embeddings files, At the top, we import PG vector, and we create it, instead of using memory vector, we create it using pg vector store.initialize. We give the same embeddings model there, but we need to provide here some configuration. Configuration such as Postgres connection options. And the connection options, you can either use a connection string, the easiest way, or you can have like port, host, database name, and so on. But the easiest one is just to provide connection string as process.env db URL that we added here in our environment variables. And then we are not done yet with the configuration. We need to give a table name. The table name, what is going to be the table name for this store? Let's do transcripts. Let's do transcripts. Columns, we can have ID column name. Come on, columns. The ID column name, let's do it ID. Let's do the embedding column name. You can specify what should be the name of the embedding. You can do embedding or vector, for example. What? I don't have text column name. Content column name. This is the content of that embedding. And there is also metadata column name, metadata. I think you can leave them out as well, but because it's going to be default, but know that you can adjust them. Is it embeddings or vector? Oh, it's vector column name, sorry. Vector column name, vector. And besides columns, you can also have a distance strategy. And this is a little bit more technical, basically meaning what function to use to calculate the similarity. There is cosine, there is whatever. Yeah, there are other methods as well, like inner product or Euclidean as well. But cosine is default, so you can leave it like this, or you can even leave it out as well. Anyway, now if I restart my application, the vector store should automatically connect with this database, with this configuration. I don't need to change anything else. The vector store will have the same add documents and stuff like that. And it should automatically handle the database creation for me. If I go into new one under tables, we don't have any tables yet, but if I'm going to go ahead and restart or run our agent, if everything is successful, it's going to connect and store the information in Postgres. We see that we cannot find the PG package, because for that we need to do npm install PG. This is for Postgres, so it's a pure dependency. Let's try to run it again. We see vector store from embeddings.js. Does not provide an export member. I forgot to do export vector store. If I do it again. How many tabs open in that browser? I don't know, a lot. And that's not even enough. What will people learn from the video? Like now, at this point, if I go to the tables, we see a new table called transcripts. If you go into the options here and enable table row count, we see that we have around 167 chunks of data. So this is not 167 videos, but because my video, one of them is 4 hours long, it divided in that many chunks. So we say that the first one is about Lance Stroll and so on, fastest ahead, Lewis Hamilton, definitely transcripts from Formula 1 videos. But if you scroll down a bit, we see that what? It's information about the bold text and React Native and so on. So this is the second video. In the metadata, there is the metadata about video ID. So this is how the filtering is supposed to work. And let's double check if filtering is working in a second. And there is this vector, which, as you can see, is a bunch of numbers. If I will, I don't know, I can copy it, maybe I don't. But you're gonna see that it's simply a bunch of numbers. So this is a better way because now it is stored in the database, so we don't have to embed and generate them every time. We can build a huge cache of this data to later interact with. This is the information. And again, let me double check in the agent in that tool for retrieval. We have here the function. But as we can see now that our vector store is a database, it would be better to provide here a filter object. And that filter object, if I'm not mistaken, is going to be added on the database layer. So it's going to completely ignore those items when it does the SQL query. So this is the filter to retrieve the documents based on the video ID. Perfect. Now I will do this, and at this moment we are still adding like those items in the database, so most probably we're going to have duplicated items. We had 150, now we have 334, but it works here like this time it didn't call the tool, but anyway. Or maybe it's a problem. Maybe it called the tool. I'm gonna comment out this await add YouTube videos to the vector store because they're already there. And I'm going to run it again to see if the filtering is working correctly. Because it's either not calling the tool or the tool is not doing, yeah, I see information, so that means that it's working correctly. Perfecto. Amazing. So this is our git add database. Postgres for the vector database. I think in the next step, we are kind of ready to integrate the chat interface. And before we do that, I want our server to be an RESTful API so that we later can interact with it by sending HTTP requests. At the moment, our agent, we interact with it by literally calling agent.invoke and invoking that, executing this file. But what I want to do is I want to create an API that I can send this question as a post request, and I can invoke this agent and get back the answer. For that, let's go ahead in the server and create the index.js file. And our server is going to be an HTTP server. We're going to create it using Express. So let's install Express, maybe course and types /express. And let's start by creating a simple import express from express, import course from course. We create the express application. We add course, which is, if you don't know, like it's not a big deal here, just add it because it's going to later help us send requests from our frontend to our backend when they will be deployed. And what I can do is I can say simply add a get request to the slash that will return hello world and start listening at port 3000, for example. Or maybe we can do here const port equal process.env.port or 3000 if it's not provided. I'll take port here, and the callback is going to be executed when the server started listening. This is a very basic bare bone HTTP server. What I can do with it is I can do node, maybe with env file, and I'm going to execute not agent but index.js. If I do that, we see server is listening on port 3000. Because this is a GET request, I can simply go to in the browser and do localhost 3000, and we see the hello world. The hello world that was sent from here. Usually, we are going to send this request. Maybe they're going to be curl request, post request, so we can also use the curl command in the terminal to send these requests. Okay, good. What I'm going to add now is not a GET request, but a POST request to the endpoint, maybe generate or query, or yeah, let's do generate. The generate is going to be like question and answer. I send a question and I expect back an answer. The query itself, I expect it from the body, and let's do console log query and return send like this. Now, because this is a post request, actually I did some changes, so I need to stop the server and run it again, or I can add, come on, to my node, I can add here at --watch. So that is going to watch any changes. If I'm going to change something here, it's going to restart. So I don't have to think about restarting it always. Perfect. Now that our server has restarted, we can send a post request to /generate. To do that, in a new terminal, I'm going to do curl dash, that is a header. Let me try send a post request using curl to /generate with a query data. Let's see what the AI will tell me. Yeah, it's the -x that I was looking for. It should be here. So I'm trying to send a post request to localhost 3000 /generate with the data, this query. What will people learn from this video and this video ID? Maybe I will take video ID as well. If I send this query, we see something. We don't know what exactly, but we see some errors and an error here as well. Cannot destructure property query from request.body. That's because we didn't add quite an important part, which is here as a middleware, we can add a express.json that will automatically transform our request body to JSON, because without that, the request body is not a JSON format. If I simply add that one, I can use it as a JSON and destructure the inputs like this. Now, if making sure that the server is running, if I send the same request again, we see hello world because that's what we send, but in the server, we see that the query is this one and the video ID is this one, meaning that I can go ahead and import the agent here from our agent.js. Let's make sure that in our agent.js, we do export const agent. We no longer interact with it directly, so I can remove this part altogether, or maybe I'm not going to remove it. Let me actually copy paste it in our index inside the generate. I'm gonna put it here. I'm gonna come to it in a second, but I need to change how we import the agent. We need to destructure it when importing because we are exporting it as a constant. So we have an agent here from agent.js, and when there is a request to /generate, we get the query, we get the video ID, and we have the interaction with agent as we had before. I'm going to do some changes. We no longer need this video ID because it's going to come from the request body. I'm not going to have this console log. I'm going to have agent.invoke and role user, and the content is going to be query, not this hard-coded one, but the query that we receive. For configuration, we have thread ID, so maybe we're also going to send the thread ID here. So let's do thread ID and video ID. Then we take the result and we return it back as results. Maybe I can do it like this. Let's see. Return the .json to send it as a JSON. And I'm going to send the last message. Maybe it's going to be too much information, but let's see what's going to happen. Now our server has restarted and we can send the same request, but we need to change it slightly to add in this -d. I'm going to add a comma here. I'm going to do a, is it an enter? Come on. It's a bit hard to edit them, but I'll do it like this. I'm going to add it here. I'm going to comment it out. Thread ID 1. I'm going to uncomment it, copy it, and comment it back. And I'm going to leave it here for you to also be able to test this endpoint easily. I'm going to go into the terminal and I'm going to send this request. It's going to already work with this query and with this video ID. And we see a lot of things, but we also see the content. And I'm thinking, should I just return the content? Is anything else important here for the front end? There is cache and so on. In response metadata, ID, model. Let me simplify it and just say res.send -content. So I'm simply going to send the content there. And if I send it again, it's going just to give me the content. You can adjust it, like depending on what information you want to send to the front end. Perfect. It works. And I think that is it for our first step into creating a RESTful and a server for our AI agent, so that in the next step our front end is going to be able to interact with this server when the user writes something in an input box. For now, let's go ahead and do git status, git add, git commit, add REST API for our backend and for the agent. Perfect. Now it is time to already, instead of doing it through curl request, it is time to integrate the front end, the client-side application, from which we're going to be able to interact with our AI agent. I don't want to spend a lot of time building it, and for that reason, I'm going to show you. I'm going to leave in the guide. Let me think. Yeah, if we look into the tutorial build AI agent with LangGraph, for the front end, what I did is I simply created this prompt and I use Anthropic to build the front end for me. So I told it, build a simple UI interface for an AI chat app with this structure, with this styling, with this and that and that. And in the end, we got like this AI chat interface. And I think it's pretty good for us. And because I don't want to focus on building the front end, we can reuse the same code here, where we can try to reuse the same LLM generation as well. I'm not sure what is going to be the result, so it's better to use it together with me. So first, let's go ahead and run npm create void at latest to generate a new React project. But this time, make sure that you are not inside the server. So if you are in server, you can do pfd to look where you are. Make sure to go one layer up to be, if you do ls, to see the server here. And now let's go ahead and do npm create void latest. Let's give the project name. Let's do chat with YouTube, or let's do here client. Let's use a framework, and the framework is going to be React. I'm going to use, should I use TypeScript? Let's use TypeScript. And that's it. Now we have a client-side project. If I'm gonna go into cd client and do npm start or npm install to install the dependencies, and then npm run dev, we're going to see a local host here. And if I open it up, we're going to see the starting point for a React application. Perfect. Let's go ahead and, as I was saying, either use this LLM to generate this prompt in an LLM, like Anthropic or in the Claude or ChatGPT, and generate the code as like that, or come here. I'm going to leave it in the comments so you have access to it. And press the source code here. We're gonna have this same client here in the source. I'm going to look at the app.tsx. I'm going to copy everything here. And I'm going to come into the client source application, paste everything here. And the same thing for, is it index.css? I think so. Let's copy everything from index.css and add it here by replacing everything like this. The only thing is that if you look into app.tsx, it tries to connect to localhost 3000. So let's change it to 3001. Let's change it to 3000 because now our backend is running on 3000. And let's try to what? To restart it by running npm run dev again. This is the API. If I open it up here, boom, here we have a chat interface. If I'm going to say, What's gonna happen? What's gonna happen in the client if I'll say hello? There was an error because probably we're gonna have to change a little bit how we do that. If we look into the app.tsx and are looking here around line 50, we have API generate, and the data here is a little bit different. It does prompt, it does thread ID, and it does video ID. Let's try to do video ID like this. In the server, in the index, what do we have? It should be the same, /generate. Instead of prompt, I'm using query. It was easier if I use the same, so let's just change query here. Thread ID is good, video ID hard-coded. Video ID hard-coded. And now if I go here and say hello, if I reload, say hello, what's going on here? If I look in the console, into the network tab, and say again, hello, send, we see that it failed. Why? It's because of a what? Response request. What's going on? Maybe our API is not running. Server, yes, failed to run index. I'm going to go ahead and restart my API, my server, and it still fails to run. No, now it says server running on this port. If I come back here and say hello, okay, now it gets to the API. Hello, I'm here to help you find information from YouTube video transcripts. Is there a specific YouTube video or topic you would like me to search for information about? I can retrieve relevant parts of a video transcript based on a query. Perfect. What we're going to do is let's go ahead and double check like we hard coded via video ID. That video ID, I'm just going to double check in the data if we have such a video ID. Yeah, we do have. And this one is this Apple style video. Let's check what will the viewer learn by following this tutorial. This is a question about a specific video. Use the tool to get how is it called, to get relevant transcripts. Okay, it's very insistent. Okay, what is that topic of the video? You see, like the one benefit of an AI agent is that it can decide like how often and how to interact with the tool, in this case a retrieval tool for the RAG system. The downside is that you lose a little bit of control, and as you can see here, some questions the tool didn't realize that it has to integrate with that, it has to call that tool. So sometimes an old school chain of calls might be better. But with right prompt engineering, with right descriptions of a tool, I think you can get like the actual results and keep the benefits of having this AI agent that decides like what to call, how often to call, and so on. So we see that based on the transcript, this video appears to be a tutorial about creating a mobile application. Perfect, amazing. So we have our front end as well. We have our client side as well. Let me go ahead and do the following. I'm going to do a git add git commit -m front end chat interface. Another issue is the agent will call a tool when you don't want it to. Yeah, that's also true. Like having like an agent as we have here, we don't say like the word there or how to do the things. We just give it a bunch of tools and we let it decide like when to call it, how to call it, and so on. So yeah, sometimes it's going to do things that you might not do, but that's the power of an autonomous agent. Mine likes to use the generate image tool anytime it writes an image generation prompt. I highly doubt you're comfortable speaking like that when you are not behind the safety of the screen. What do you mean? Oh, you have some beef there. Chill, guys. It's okay. Okay, so what do we want to do next, guys? What do I want to do next? I know what I want to do next. The next step is being able to start conversation about new videos, because right now in our Neon database we pre-filled it with some transcripts from 2 different videos, and we can talk about those videos by hard coding some data. What I want to do next is to be able to embed and index any kind of video that the user wants to talk about. For that, we need to allow that to happen, and one step before reaching that, because we're going to do that with BrightData, before we do that, I want to host our both client side and server side, so that we're gonna see like how we can connect BrightData back to our system to get this data about the video transcripts. So what we're going to do is we now are going to host our server with Genezio. Go ahead, genezio.com, where you can follow the link in the description. By the way, this part of the video is sponsored by Genezio, so thank you very much, Genezio, for making this possible. And you can go on Genezio, you're gonna go into products, deployment platform, and you can go ahead in the documentation, create an account, and you can see different frameworks and tutorials how to deploy them. In the Genezio CLI, let's go ahead and install Genezio first by doing npm install genezio-g. In the terminal, I'm going to do that here. I already have it installed, but that is not bad to update it as well. And then we have to run Genezio login. Let me double check that. Yeah, need this one, but make sure to create a Genezio account. And then you're going to need the deployment, the API key from there. And you're going to run Genezio. Is it login? I forgot like how to connect it with our. Yes, Genezio login to the platform. So if you run Genezio login, you're going to connect it with your account. After that, we can start deploying our application. But before deploying, I'm going to create a Genezio.yaml file that will specify how do we want to deploy our both server and the client. This YAML, I will also provide it in the guide, so you don't have to write it, but I will write it quickly, so I will comment like what everything means. So first we have, let me do it like this. So I have a reference. So the name is going to be the name of our project. Let's call it YouTube chat application. You can specify the region where you want to deploy it, for example, US East 1, and let's do YAML version 2. Next, we have two things. One of them is the backend, and another one later is going to be the front end. But first, let's focus on the backend. The backend, you specify the path to it, so the path is this server. So let's say server. The language, we're going to say name is JS, and you can also specify the package manager. In my case, I will specify npm. Now back in this line with language, we're going to also have an environment that, I don't know, we'll have, for example, the API URL, which is going to be the actual URL of our API. Let's say ABC for a second. After that, in our backend, we're going to have some functions. The function that we're going to have, let's say that is going to be name API. Simply API. The path to that function is going to be, because relative to the backend path server, our function is going to be this path. So it's going to be /. The handler, or the entry actually, the entry is going to be index file. So index.js. And the type is going to be HTTP server. So Genezio is going to run a function that is going to serve our Express application. Now in this environment API URL, I want the whole backend to have access to the URL of where is our backend deployed. So we can access it dynamically like this by saying that I will look into the backend, so backend dot functions dot name API dot URL, and this is going to be provided as an environment variable API URL everywhere in our backend. We're gonna see why we need it later. Now that we have our backend done, let's go ahead and focus on the front end. In case of a front end, the path is going to be client. We're going to say what do we want to publish, and we're going to publish the dist folder. The dist folder is something that is going to be generated if we run a script when we want to deploy npm run build. So if we run npm run build in the client, it's going to generate dist folder, and that dist folder is what we want to send and publish. Finally, we need some environment here as well, as we had on the backend. Something similar to here. Where is it? We need some spaces. But in this case, it's a little bit differently. It should be prefixed with void underscore API URL. If you do void, it's going to be accessible in the client-side code there. That's it. Now let's go ahead, open the terminal and try to, you can also do Genezio local to run it locally, or you can do Genezio deploy to deploy it to Genezio hosting. It says that we detect that Anthropic and OpenAI and DB URL are not set remotely. Do you want us to set them for you? Let's do yes. And I think it's going to look through this configuration and set them remotely. Everything on the backend work correctly. The frontend, this does not exist. I was expecting it to run automatically npm run build. Oh, I think the problem is here. It should be scripts, not script. Because I can run it myself, but it should run automatically when doing Genezio deployed. So let's try again by changing it to scripts. And what do we see? We see that the function is deployed. We see that it's building the front end. We see that because we didn't provide any subdomain, it automatically added it for us in this Genezio YAML, like this, automatically generated. We see the link to the application dashboard and a link to the front end. If I open front end, what's going to happen? We see that our AI chat has been hosted and we can say hello. And if it can connect with our backend as well, that means that everything is perfectly configured. And as we can see, it actually is. And we can ask things about the video. What is the video about? And it's going to interact with our Neon database. It didn't call the tool, but later it will. Everything works. Or maybe not. Let me actually try. What is the video topic based on the retrieved transcripts? Being more specific, like what it should do, like, I don't have any retrieved transcript yet. To search, no, you actually have. You actually have. Just try it. Trust me, you have transcripts. Will it believe me? I think it does, because it's, based on the retrieved transcript, the video appears to be about app development, blah, 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 and so on and so on. Perfect. Amazing. So this URL now is publicly accessible because we use Genezio to host it very easily. I will give it to you, but I don't know if I should give it to you, but you saw it, so it depends. If we open here Genezio in the dashboard, we see that we have a function and we have a front end. If you want to debug the functions, you're going to go into the monitoring or into the logs, and you're going to see different logs from your function calls. You actually here, just try it. This is the input. So yeah, this is how easy it is to deploy full stack applications, both front-end and back-end with Genezio. Perfect. Now, in the next step, let me actually go ahead and do a git add deploy to Genezio. In the next step, we are going to add functionalities to interact with BrightData and to scrape the transcripts of the videos that the user needs. Seems like convex would be a better option for the database. How did you settle on Neon? I just wanted something simple like Postgres, and that's why, like when I need just a simple bare-bone Postgres, I go to Neon. But I haven't worked with convex yet, actually, and I'm pretty sure like if it's built like exactly for that one, it would be better. But it's super simple to change. The only thing that you would have to change is in the server, in our embedding here in the vector store, you're going to initialize a different vector store. And Langchain integrates with convex, so it's possible like that as well. Give me 1 second. I'm going to take a very, very short break, and I come back and we continue with our implementation. Hello. So let me just double check something. I'm thinking how to design the user experience of starting of indexing a video. That's what I wanted to say. My initial idea was before we start, and actually I had it, before we start an AI chat, we have an input, we have an input where we put the video ID, not the video ID, the video URL, and then we take the URL, we scrape it, we index it, and only then we open up the chat and we can talk with that video. Now that I'm thinking, wouldn't it be better if we just have a chat interface and we paste a YouTube video here and we start talking about it, then we paste another video here and we talk about it, and so on. What do you think? How should we index videos? More free flow in a chat way where our AI agent is going to have a tool that knows how to index videos, or a more structured way where we have like an input, give me the video ID, I'm going to index it, and then we open a chat with that video. Let me know in the comments, like in the chat, what do you think would be better? What you would like to see, for example? Come on. Because let me close some of the stuff down. This is, we need it. I don't need these ones. Because in any way we're going to use BrightData to fetch or to scrape the video data from YouTube. We already saw how to do that, and what we did is we went to BrightData, we created an account, then under web scrapers, we go to web scrapers library, we are searching for YouTube, and we see that there are 8 different scrapers for YouTube, but we are interested in this collect videos by URL. So I'm going to click on it, scraper API, let's do next. And here in the API request builder, we add the API token, we add some inputs, and we see a curl command. In this part, we can also see how we can do that from Node using fetch. If I do that, I can, and also if I'm going to do a couple of things, I need to include the errors, that's good, and I don't need to deliver results to S3 storage. I'm going to unselect that one, but I want to send it to a webhook. Sending the response to a webhook, the way it's going to work is, oh, I didn't show the parts. Let me do it again. So the thing is that we are still going to use BrightData. So going on BrightData dashboard, we're going to go under web scrapers. Come on, why it's not changing? Here. So BrightData dashboard, web scrapers library, and we are searching for YouTube. We're looking at the YouTube videos post, and we select scraper API. Here we see that we already saw in the API request builder that we just send the URL of a video, and as a result, we're gonna get the scrape data, including the transcript. We're going to configure it a little bit. For example, I'm going to delete and leave only one input. It's going to be easier for me to see there. I'm going to deselect deliver results to external storage. And I'm going to send to webhook. That means that when we send this request to BrightData dataset trigger, we are sending a request to start the scraping job. But because scraping jobs can be, it's a long task, it can be a couple of seconds, but if there is lots of data, it can be minutes, depending on the collection. This one, we see that on average is 7 seconds. Anyway, instead of waiting for the result, we just trigger the request, and then we can either send another request to check the status, or we can give BrightData a URL that BrightData is going to call when it finishes the scraping job. That's what we're going to do. We're going to do here, let's do HTTP example.com, and then later we're going to fetch it, change it. Let's do example.com/webhook. This means that, hey, BrightData, when you finish scraping this job, send this data here. And the file format, I'm going to leave it to JSON. And in the example request, instead of Linux bash, I'm going to do node fetch. Here is a good example of how we can send this request. Let me copy it. Let's go in our server, and I'm going to create a new file. Let's call it BrightData.js, and let's export const start or trigger YouTube video scrape. We have the URL of the video, and what we have to do is we are going to paste the code that BrightData gave us. So we're going to change it a little bit. For example, we do not need to import fetch from anywhere. I'm going to remove it because it's going to be there. In the data, this is the input. So this is the URL that is going to be sent here. So what I'm going to do is maybe I'm going to call this trigger scrape input with this URL. Not with this URL, with this URL. And here I'm going to simply take the URL from the parameters and send it to BrightData like this. Maybe we can adjust it to send multiple videos as well, but for now it's good like this. Then what we do here is we send a fetch to this long URL, but let's break it down. For example, I'm going to break it down into maybe like this. Everything until /trigger. Let's do here const BrightData trigger URL is going to be equal to this one. Let's take it and let's transform this URL into a template string with the backticks. Come on. Backtick here, so that we can replace this URL with simply saying BrightData trigger URL. Then we have dataset ID. Dataset ID identifies this YouTube video post dataset. It can also be dynamic if you want. I will leave it like this. Endpoint is where do we want to send the results to? Where do we want to send the results to? Well, we want to send it back to our API, back to our server. So in our index here, let's go ahead and create a post request called webhook request response, and let's simply go console log request.body to see what data we're going to receive here. Now we have to say, hey BrightData, simply call back the server here at /webhook. But the URL, we don't know. We can hard code it from Genezio platform. But remember, in Genezio YAML, we said that we're going to give an environment variable called API URL. That's why we need it. We need it to dynamically say, hey, the const callback or webhook URL is going to be this one, but actually it's going to be, I'm going to change here to process.env.api URL /webhook. This /webhook is important because it's our endpoint implemented here. Okay, so let's change the endpoint here. Pay attention of how we're going to do it. This http example.com/webhook until the end, we're going to delete and replace it with the webhook URL. Then we have format JSON is good, uncompressed webhook true, and include errors true. Everything is good here. Now the method is post. Authorization headers. This is the BrightData your API key, so it's better to take it from here and add it to the environment variables as BrightData API key. And back here, we're going to replace it again with process.env.bright. Come on, it should be BrightData API key. Then content type JSON, and for the body we give this data. I don't like the .then, so what I'm going to do, I'm going to, before fetch, I'm going to say const response equal await. Then I'm going to put here, I'm gonna stop, and what we have, then we have data, so const data equal await response.json, and that's it. And maybe you can also do a try catch. Maybe we can do result, and we can do console log result. And this is our function that is going to trigger a scraping job for a video URL. We can do that by, again, we simply called it here. Maybe we should call it at the end, right? Not at the top. So we can give here a YouTube URL like this one. And we can do, let's do cd server clear, and I'm going to do node env file, and let's run the BrightData.js, this function. So we see that as a result we get the snapshot ID. If we look into the BrightData logs, we should have a new job here, and if we look at this snapshot ID ending with 9Q, this is the last one here, it took 5 seconds to complete. We can download, or we can check what happened there with the endpoint. We haven't deployed it yet, so give me a second. But if we look here back in our API request builder, and you put here the URL of our Genezio. Let's see. Let's first stop this one and let's deploy our update. Our update has this /webhook endpoint. Yeah, because we need to go one above to be in the root. We detected a new BrightData. Let's set it remotely automatically for us. So we see that the function API is this URL, so I can copy it and basically use this one in the notify URL, or no, in the send webhook. So send to webhook URL, this URL of my function. You can also open it in the dashboard. And here you're going to see the function URL. And we need to also do /webhook. You can also press test webhook, and this is going to send a test result, and we see test sent successfully. If we go into the Genezio, into the logs, we're going to see a test, a request body. This was the test that was sent for us, and we received it in our backend. In the /webhook. That means that now if I am going to invoke the same function again, for example, trigger YouTube video with this URL by this is a little bit hacky right now, but in a second we're going to connect it with our API and it's going to make a lot more sense. But I want to trigger a new scraping job and I want it to automatically call our webhook. So if I go into the server and do node BrightData.js that is calling this function, we see this snapshot, and this snapshot, if I look into the logs, it's ready and it's supposed to call our backend. And if I reload, we see, yes, we did. Actually, no, we didn't. You know why? I know why, because I'm running it locally, and locally the webhook URL is not set, it's not correct. So that's why we need to do it remotely. The next question is, when should I call this trigger YouTube video scrape? Should I create a tool out of it and give it to my, let's try to create it as a tool. Let's try to create it as a tool. I haven't tried it creating it as a tool. Make sure to remove it from here. As a tool in our agent. When I was preparing, I did it like with a input here. So you input the YouTube video URL and then you talk with it. But I think it would make more sense to see at least how we can do it with a tool in our agent. So let's go ahead in our agent and create here a tool. Const trigger YouTube scrape tool. Now it has a function that does something and some configuration. For example, name, it can be trigger YouTube scrape tool, and description, trigger the scraping of a YouTube video using the URL. The tool will start a scraping
job that usually I will give it more context to know how to use it. Maybe I can do it even in new lines like this. The tool that usually takes around 7 seconds. Maybe later we can give it a tool to also ask for the status of jobs. The tool will return the job ID that can be used to check the status of a scraping job. This is a bit... The tool will return the job ID. Should I just, from BrightData here, because it returns an object with snapshot ID. Should I just return snapshot ID? I think so. Let's just do return results dot snapshot ID. The tool will return the snapshot / job ID that can be used. Okay. Use the tool only if the video is not in the vector store already. In the schema, we need the URL, and we are going to get it here as URL. What we need to do with it is we need to say, hey, snapshot ID, return, trigger YouTube video from BrightData. Let's do console.log, triggering YouTube video scrape, and this one. That's cool, because now if I'm going to make sure to run the server and run the frontend locally, and if I'm going to go to localhost, what's the API for the local host? It's this one. If I will say, I will go ahead and take a YouTube URL. But wait a second. I forgot one thing. I forgot to take the trigger YouTube video scrape tool and give it to my agent. Now, if I'm gonna go ahead and take a video for, let me see what exactly I want here. I don't know what to say. I'm going to do also F1. So if I take this URL and send it here, can we talk about this? And if I send, this is a very interesting, this is a very specific prompt saying that, hey, I want to scrape this video. Let's see what's going to do, what's going to happen. If I look in the logs for our server, we see that triggering YouTube scrape job for this video ID, and it's not finished yet. YouTube video scrape triggered. So it has a snapshot ID, and what it does. Based on the information gathered from the video transcript, I can provide you with a summary of a YouTube video summary, building a custom scrolling component in React Native. No, that's not really true. That's not really true, and we are going to have to adjust it a little bit. That's because now that we are working with URLs and video IDs like this, it's not longer going to be part, like in the retrieve tool, it's no longer going to be the video ID here. So I'm going to remove this configurable video ID, or maybe let me do it like this. And I'm going to take it from here, from the parameters that our tool is going to receive. And it's going to be the LLM that is going to decide what the video ID is. So again, giving more control to the LLM. In here, we're going to say in the schema that we have the video ID, but we can also describe the ID of a video to retrieve. Yeah. For a specific YouTube video. Now, if I'm going to go ahead and say the same thing, can we talk about this? It's going to do that trigger. And then it's going to try to use the data from Neon. The thing is that it's not ready yet. Like our trigger, even though we are triggering it, the data is not stored in the database yet. We didn't complete the loop yet. So that's why we see, I apologize, but it looks like the video content is still being processed and is available for me to retrieve information yet. This typically takes around 7 seconds, but sometimes it can take a bit longer. That means that even though the scraping job was correctly triggered, as we can see here, it's correctly triggered by our agent. We need to deploy it and make sure that our /webhook receives the request.body. But not only do we need to receive a request.body, we need to index them. How do we do that? Well, request.body is basically similar to this data.js. It's an array with videos. It can be one video, it can be multiple videos at the same time. We have embeddings, which has a function add video to vector store, which expects the video data. So in our server index in the webhook, what we need to do is we need to in a simple way, we need to do await, making it async first, add video to vector store, request.body /0, because the body is going to be an array. And I can show you that by looking into the logs of Genezio logs, we see body is an array. But if you want to store all of them, what we have to do is we have to say request.body.map. For every single video data there, we want to add it to the vector store. And because this is an array of promises, we're going to put it into await promise.all and say that, hey, await storing all the data and only then finish it. Return OK. So now if we deploy, I will probably do that. There is one more small thing that we need to take care of. And instead of showing you the problem first, let me explain it. Usually the Express are going to limit how big the body of the post request can be. However, in our case, if we are if we are scraping a podcast of 4 hours, that's going to have a lot of data. So it can be a couple of kilobytes, a couple of 100 kilobytes. So in this express.json, we can give an option here to increase the limit of that data. I can even do 200 megabytes just to make sure that it's going to work. Now that I have this one here, let me go ahead and deploy everything to production using Genezio deploy. And we're no longer going to test it locally. We're going to test it the deployed one. So we see frontend URL. You can copy it. We can go here. And we can start by copying a URL. Let's go back to our application and let's talk about, and let's do the video URL. Now, if we look really quickly here on BrightData, I think it's supposed to trigger a new job here. Yes, it's running. And this BrightData job should call back our API at /webhook. We're going to see that in the logs here. I don't think we logged anything, but we see that the function call at 51 just now, which means that in Neon, if everything worked correctly, in Neon database, we should already have information about a video from a new video ID, that is this 4L at the end. So if I look here in the Neon database, this is still that one. And if I scroll, there are a lot of them. So let's do like this. This is the last page. If I look at the end, it didn't work, right? I don't think it did. I need to double check if it actually was scraped correctly. So video ID is this one. Can I do a filter here where metadata, but metadata is a oh no, yeah, here it is. Louis, congrats. You see, it's a small video, so it's 4 chunks at the end. If I search here, you see that these 4 chunks are about this video. So what I can say here now is it ready yet? And it's supposed to already look into the Neon database instead of triggering a new one. Did it trigger a new one? This is now is 53, so I don't see a new job being triggered, which is very good. And the answer is great news. The video content is now available. Based on what I've retrieved, this appeared to be a video about Formula 1 racing, specifically featuring Lewis Hamilton. Here is what I can tell you from the content. What was Lewis' last words? Last words, not that bad, like last words in the interview. Let's see if it can understand this kind of stuff. Based on we'll stay positive, we'll keep our heads high and keep pushing forward. Perfect. Now I can go ahead and take a new video, for example, from our channel, and say, hey, come on, live. Let's take this Lucas video. And we can continue here as well. Can we talk about this video and provide the video? It's supposed to trigger a new scraping job. Let's see. Yes, it's running. So this is all done by the AI agent. It's crazy. And after some time, it's going to add new stuff in our transcripts table. We're gonna already have 639, but this video is huge, so that's why it took a little bit of time. Is it ready? So based on the content retrieve at around 42 minutes mark, I'm not sure like why it said that. At this point of the video, Lucas appears to be wrapping up the tutorial live stream. He's just finished implementing some functionalities related to making items pressable. He just finished like that. What is the tutorial about? So basically, I can talk with this tutorial, with this YouTube video. Let me try to find something that Lucas maybe said. What kind of list? Let's do. What kind of list is that tutorial teaching? Shall we do that? That's going to be the next question. So this beginner-friendly tutorial where Lucas is teaching the viewers how to build Apple News clone in React Native, like that. What kind of list is Lucas teaching? So how it's going to work is going to find from all of the transcripts here, from around 300 transcripts that are more similar to that. Maybe this one around here. And based on that, it's going to analyze and answer the question. So let's see. Maybe something even more specific. How specific do we want to get? But yeah, let's see what's the answer. And now because we are using the AI model, we can even combine multiple videos. Error processing the request. That's interesting. I'm wondering why. I don't know. Maybe time limit, I don't know. But what I wanted to try to do is go back to a previous video, for example, the Lewis. What was Lewis excited about? And I think it should link it to the previous video without scraping new data, because it already has it in the database. The video where it's earlier was about Formula 1. Would you like me? Yeah, the question was about the previous video with ID. Maybe this one. Now I can properly answer your question. What kind of was discussing? Okay. Key points about qualifying session. Perfect. So I think this is better because it's very flexible. It can start scraping like different jobs. And even if we try to do that again, I hope it's not going to add new items in the database. Because if it's smart enough, it should first check if it has information about that. So even if I remove and restart the chat from scratch and say, can we talk about and the video about Lucas, I hope it's not going to start a scraping job, but it's not up to us, it's up to the agent. And it actually indeed tried to do that. Maybe we can instruct it better through the description of our agents. Use the tool only if the video is not in the vector store already. So we need to tell it like check the vector store first, because it added more items here. Also, you can add a table with video IDs where you're going to save the status so that it's easier to understand if it has videos or not. Before calling this tool, make sure that it is not already in the vector store. So maybe like this, maybe with an additional tool to check the status of a video, it can also improve like how our AI is going to work. But the last change that I want to do here is that now from the client, we are no longer having to send the video ID manually, because that is the agent is going to understand from the context of what we are talking about, is going to understand like the video. Let's see, and in the backend, in the server here, in the index, we don't need in the generate the video ID. Again, this is something that the chat is going to understand through the messages that it worked with. Perfect, so now I can deploy it again. And I think with this, we have a pretty cool RAG system that we can use to talk with YouTube videos. Lucas filling in for Vadim, who will return next week. He's a developer, video content, and so on. All right, what will you guys build with this one? Let me know in the comments below, because I believe this system opens up so many opportunities and possibilities. I'm thinking you can build like a Chrome extension where you go in a video and you can already pop up here and chat with that video. Like, give me the summary. What did he say at the beginning? What did he say at the end? Like, it can be a great learning resource on top of YouTube or other sources from the internet that can change the way we are consuming content. Another idea that I have that this might serve as a core for implementing can be something. For example, we as notjust.dev have a lot of content on our channel. But sometimes it's hard to remember, or for a new students to know like where did we use what. So for example, if you're interested in animation, I would go into a tool, into a chat box and say, in what video did they talk about, or give me the video ID or better URL for videos about F1 you know about. I think without even changing anything, it might work, because it will look at the context, it will check F1 and will find like these videos. And let's say I don't have pre-existing list of videos. I would need to specifically available tools. However, tools I have designed retrieve information from videos already know about by providing a video ID, or to scrape new videos by providing video URLs. Okay, so yeah, it doesn't have a tool to look at video. Yeah. Or to scrape new videos. Provide videos. What if it just uses the same tool? It should work. It should work. We generate with the retrieve. It needs a query and a video ID. Yeah. This video ID. Yeah. Look, I was not sharing it, but I wanted for it to give me a list of videos about Formula 1. I think for that to work, we just need to create a new tool. Let me try. I'm really curious to see. I'll create a new tool called Retrieve Similar Videos. And it's not going to get the video ID, but it's going to get the query. It's not going to get configuration. And it's going to find like the top 3 videos about that. And it's not going to have any filter, looking at all the data in the database. It's not going to serialize the content of a page, but it's going to map over doc.metadata.video ID. So IDs, and then we're going to return IDs. Retrieve similar videos, description. Retrieve the IDs of the most similar videos to the query. And I don't have this video ID. So that's another tool that I can give to my agent. And I think with that tool, if I deploy, we should be able to talk with all the videos there. And by adding these kind of tools, like maybe you add a tool to index a channel in all of his videos, and then get a tutor based on a creator. So you index the whole thing that he said, and then you create a chatbot based on that creator. That's actually a very good idea. Let me see what's happening. It deployed. Let's see the same question again. Let's see if it now can give me a list of video URLs. I found a Formula 1 related video in the database. Here is the details, video ID, and this is the video link. Perfect. Is the highlights, but there is one more. You can access the F1 video directly through the I know what happened there, because even though there are more items there about F1, the similarity search here of similar videos only received 3 top chunks, and the 3 top chunks might be for the same video. So that's why it only gave me 1 video instead of more. So maybe you can increase here from 3 chunks to 30 most similar chunks to that query. I don't know. Or you can have another table where you have videos and what are they about, with a little bit shorter description, with a shorter vector based on the description, so that you can also search like this for the videos as well. Perfect. Love it. And I hope you enjoy this one as well. All the links, all the documentation and the guide are going to be available through the guide link in the description below. So just simply go in the description and you'll find a link to the step-by-step guide. I'm going to put there also the source code so you can look at it and maybe implement something of your own, play with it. Like, I'm so excited with the possibilities of this one and everything related to AI nowadays. It looks like magic. Like, we put stuff together, we put the tools together, and then it can do anything. We just have to ask it the right question. So I hope you enjoy this one. I hope you learn something new, learn new about AI agents, about RAG system. Thank you very much for our sponsors, BrightData, that allowed us to get access to any data on the internet, which is so important nowadays in the AI age to have access to data. And also Genezio for helping us host, deploy our application in a very scalable environment, in a server that can scale with our application. Thank you everyone who joined. If you have more ideas, if you'd like to learn more about AI or mobile development or anything else, let me know in the comments below. I'm going to read them and note it down to build something for you in the next week. If you enjoy this one, make sure to subscribe, and I'll see you guys next week. Bye bye.